This is my 5th attempt at making this video. I should make a blooper reel. But it'd be just me. Alright, anyways. Let's go to this question here. So, you can see traces of what I tried previously. So, I should actually, there should be like little arrows here. This is a line that goes forever on both sides, right? And then an angle is made by array. Now, array is, it's part of a line, right? So this would be array, I guess. It starts at one point and goes forever, and that's what the arrow says, to the forever on the other side. Or it could obviously go this way. All right. So this angle here, let me just go over names here. This angle that measures 37 is made by these two parts of a line, right? That meet at a vertex called point B. And we use these three letters to name the angle called 37 degrees. And the name of this angle is angle, and this is a symbol for angle. Angle made up this line segment C to B and then to A. Notice that the vertex is always in the middle. Let's name this angle here. This angle would be angle C to vertex, right? B and then to D. C, B, D. Right, but it's made of two different rays. Okay. Talk about this guy over here for a second. Well, the vertex is B, so angle, the symbol for angle. Vertex is B, but it's made up of this guy over here, which we'll call DB, and this guy over here, which is called, we call EB or BE, doesn't matter. Right? As long as the vertex is in the middle. Well, what are we looking for here? The measure of angle CBA, C, here's CBA, we're talking about this guy, is equal to the measure of angle DBE. So let's look for DBE. Here's D, the vertex B, and the ray or side line segment BE. So it's this guy here. Are these two the same? And we talked about this in class. Vertical angles, two lines that intersect, create four angles where opposite angles are the same value. So if that's 37, this guy's 37. So that one is true. The sum of the angles CBA, so let me erase this. Angle CBA, which is this guy over here. This angle CBA and DBE. Where's DBE? And this angle over here. If I add these two, equals to 180 degrees. Absolutely not. One is 37, the other one's 37, so they do not add up to 180. So that's garbage. Measure of angle CBD. C, B is the vertex, and D, so we're talking about this angle right here. Right, talking about this angle, is equal to the measure of angle ABE. And ABE is this guy made, right? Angle AB is formed by these two rays, and they're exactly the same, right? Whatever this angle is, whatever, let's call it X. This guy is also X because they're vertical angles. So that's true. This one was true. This one's false. Sum of the angles CBD, so let's go for angle CBD. C, vertex B, this angle right here. Okay. And angle CBA, CBA, and this angle over here. So these two angles equal to 180. Well, that is true. Look, it's a straight line, right? That's 180, and we split that 180 into two. This being angle CBD, and this angle being CBA. So if I add up these two angles, would they equal 180? Yeah, it's a straight line, right? So in the straight line, that angle that's formed, it's 180. So that's definitely true. The sum of the angles, the sum of the measure of the angles CBA CBA, which is this guy right here. Right, angle CBA, look at the vertex. And angle DBE, and its opposite on the other side, equals 90 degrees. Absolutely not. They're not complementary angles, right? Remember, angles that add up to 90, first of all, you have to have a 90 degree. Imagine this angle. Here's a symbol for 90 degrees. And then I come here and I cut that 90 degree angle into two parts, whatever it is. Let's call this 25 degrees. Let's call this 65 degrees. Are these two add up to 90? Yes, they do. And what are they also called? Complementary. Oh, by the way, these two angles here that add up to 180 are called, so these are called supplementary, and these are called complementary. Okay. Maybe I have to charge my computer. So we're done with that one. 2. Ooh. Line A, B, and CD are parallel. Find the measures of the three angles. I think the three, well, there were like, I guess the picture doesn't show up, and I forget. But let's see if we can find all the angles. It says three angles. On your test, it'll probably be something like this. Hey, find this angle. Find this angle, find this angle, find this angle. You know what? Let's just find all of them, and then we don't have to worry about it. So, things I know already. If that's 157, this guy is 157. Vertical angles, they're exactly the same. If I know this is 157, this is 157, can I find this guy here? I can. I can do 180 minus 157. 10 minus 3, 10 minus 7 is 3. 7 minus 5. So this angle here, the missing angle is 23. And guess what? If that's 23, this angle here on the other side is also 23. So let me put in 23 degrees. Now we have this triangle in the middle, right? We have this triangle right here. And what do we know about a triangle? The sum of all the angles in the triangle is 180. So I can do 180 minus 42 minus 23, and we can find that missing angle. 180 minus 42 minus 23, and that's going to give us 150. So this missing angle here, and I'm going to erase the screen, this guy over here, and I'll write 115. And if I know that's 115, guess what this angle here is? 115. Okay. Can I find more? Yeah, I absolutely can find more. If this angle is 42, right? If this angle is 42, can you guys find this one? What would that be? Well, this is literally what you're looking at, right? So we know this is 180. A piece of it is 42. What's this guy here? Well, you do 180 minus 42, and you get 38. So this guy's 138. Sorry, 138 degrees, right? And if that guy is 138 degrees, you want to know who else is 138 degrees? And let me just draw this a little better. Try to ignore everything. Look, same thing. This guy 138 degrees, which means this guy right here is also 138 degrees. Why? Because they are both in the same exact position, the top right-hand corner, which means they're corresponding. So that's 138. 1 second. All right, so, sorry. So if that's 138, this guy is 138. Now, if That's got 138. Can you find this angle right here? This guy right here? Well, you can, because we know that this is a straight line, right? This huge straight line, which means this whole angle is 180. So if I cut that into two parts and I tell you that one of them is 138, guess what? This is 42. And you can also could have told me that was 42 because this 42 on top here and this 42 are alternate interior. Right, so that's 42, that's 42. Now we have this angle here. Can you find that angle? Well, it's a triangle. So again, 180 minus 115 minus 42. Look how easy that is. 180 minus 115 minus 42, and that gives us a whopping 0.3 degrees. Just in case they ask you, can you find this angle on this side here? This angle would be 23 degrees as well. Okay. All right, so triangle CDA. Let's identify CDA. First of all, CDA is this triangle right here. This is C, that triangle. So imagine that triangle, right? We're doing that what we did that. Get some colors, and we rotate that CDA 180 degrees. So if I take this, something that looks and it's pointing down right now, rotate at 180, it's going to now point the other way, right? So let me just make this a little bit nicer. So I had the triangle. Oh, I had the triangle. Oops. I'm going to. Oops, way too big. No, way too big. Yeah, a little better. So I had this triangle. Right, triangle CDA, and we're going to rotate it. And after the rotation, it looks like this. It's already here, done for us. Right? And they're saying that it's rotated. And it got rotated, now it's pointing up. Right? So it's the same triangle. That's what I'm trying to tell you. Same triangle. All the sides are the same. Just it's 180 degrees the other way. And then ECB, and then triangle ECB is the image of triangle ABC. Right? So this, the one that I haven't shaded yet, is the image of the green one after 100. So we took the green one and rotated again. Let's do it in a different color. So we took the green one, rotated again, 180, and now it's pointing down again. Right? So it's the same triangle, rotated. Right? So here's an arrow that was pointing down, rotated 100 degrees, 180 degrees, pointing up. Now it's pointing down. It's the same arrow. Right? So all the parts are exactly the same. All the lengths are exactly the same. So identify, so the first, so maybe you want to go, and I don't want to make this very messy, but just as an example, I'm going to draw a line here. This line is congruent to this line, it's congruent to that line, right? It's the same line, so it's the same triangle, right? Upside down, then upside down again. So this bottom, the base, I guess let's call it the base, is the same. Those three are the base. Okay, so identify at least two pair of congruent angles. Right, so let's look at some angles here. This angle right here. Okay, let's call that angle CDA. Let's keep it right. The vertex is this CDA. On the green triangle, what angle would that be? So let's imagine rotating this guy 180 degrees. Let's see if I can actually do that. All right, so imagine rotating this. I'll make a little color. All right, so, oh my God. Let's see if I can rotate it with my manually. So let me see if I can highlight this guy. I can. And I'm going to rotate this 180 degrees. So, oh, I can. Look at that. Where would it end up? It would end up right here. Right, so if you rotate that, it ends up this being right here in this corner. What's that angle? Well, that angle is the angle C. vertex is now called B, right? The corner. C, B, A. And if you wanted to write it A, B, C, that's completely fine. So, and well, there you go. At least two pairs of congruent. So we want another one. Well, and this one, so then again, if you rotate this, can you figure out another angle that are this, another pair? Well, the other pair would be this. Well, how about this guy right here? The one on the top. Let me change colors. That angle here, right at the tip of the triangle, it's angle DAC. And in this triangle, in the green triangle, what would it be called? It would be called A and the vertex CB. So that's another pair of congruent triangles. 1 second. Okay, so that's what they were asking for you to recognize. And they could have also said, hey, can you tell me two lines that are congruent? Well, this line right here, AB, this line right here, CE, and this line right here, DC, they're all congruent, right? Or you could have talked about these sides as well. Okay. Let's see if the next question does that. All right. I don't think this question was necessary, but nevertheless, here are two intersecting lines, right? So anytime you have two intersecting lines crossing, we create four angles. We get two pairs of congruent angles, right? So that's 108. This guy on this side is also 108. They're asking for angle BEC. BEC, so I just happen to get that right. Just to complete this, can somebody tell me what this angle and what this angle would be? Well, you would do 180 minus 108. And you would tell me that this is 72, and because this is 72, the other side is 72. Now, if you got any two angles together, right, you'll notice that so if I took these two right here, right, you notice that this is 108, and this is 72, and they add up to 108. If I decided to take these two at the bottom, so let's say these two at the bottom, right, this is 72, and this is 108. So any straight line, the sum of the angles is 180. That's very, very handy to know. Claire created figure A. Here's figure A. Figure A, she created that figure. And then she created figure A by translating triangle C and then translating triangle D. Okay, so she translated triangle C. So what's a translation? A translation is when you take something like this and you move it left or right or up and down. Never diagonal, left or right or up and down. Right, so if I move this triangle, right, left and right, look at that, left and right. So she took triangle C, the pink one, and she moved it. And she translated, right? So she moved it a little bit to the right and then up. Okay. Likewise, the translation, you can move it up and down, right? So that's a translation. All right, so let's see what she did. So she took figure A is congruent to figure B. Is figure A, this figure, congruent to figure B? Absolutely not. They're not the same. Okay? Figure B is a translation of figure A. Absolutely not. This figure, as it is not a translation of that. In order to be a translation, well, figure A, first of all, is a rectangle. So if it had ended up as a rectangle down here somewhere, then it would have been a translation. Okay, so that's not true at all. Triangle C, now we're talking. See, this triangle, the pink triangle, is congruent to triangle C prime. It's congruent to this triangle. Yes. How do I know that? Because it was through a rigid transformation, right? How C got to C prime was through translation, and a translation is a rigid transformation, which means everything, the shape and the size stayed the same. Nothing changed. So no, no, yes. Then triangle D, and look at triangle D. It's exactly the same triangle, right? Translated something to the right and then a little bit down. That's triangle D. Okay. Describe a sequence of transformations that shows polygon A is congruent to polygon B. So if you can prove that through a sequence of transformation that A ended up being B, then they are congruent. Sorry for the breaks. I'm currently printing the review sheet. So if I can take this guy here, and hopefully you'll do the same thing I'm doing tomorrow. No, on Thursday. So we want to prove that this guy over here ended up being this guy, whether it's the rotation, so either you rotate it, reflection, what's the last one? Translation. Right, a combination of any of those. So let's see. Well, you can practice. So I'm going to draw a line here. There's my mirror. Right. You don't have to do this. You can just write it. That's fine. But I want to do this. So I'm actually going to pretend there's a mirror right here. Okay. And I'm going to reflect this guy, this shape here, reflect it over this of a horizontal line. We don't have a X or Y axis, but this would be your X axis if that was an X axis. So we're going to reflect this over here. So let's reflect. This point would be here. This point would be here. This point would be 2 units away, so 1, 2. This one would be 3 units away, so from the line of reflection, we would count 1, 2, 3. And then we have the last point would be 1, 2, 3, and then on the other side, 1, 2, 3. So there. And it's like this, like this, like this, like this, like this, right? All right, did I mess up somewhere? Well, this line should be obvious. Okay, there. So definitely reflection. And then a translation to the right. To the right. Ta-da! So by reflecting and translating this polygon A over a horizontal line, or if you had coordinate plane, or it could have been over the x-axis, and then a translation to the right. Yeah, that's what you need to write down to prove that this guy here, right, ended up at B. And you can, if you, so when by reflecting this over a horizontal line and then translating, A would be exactly on top of B, proving that they're congruent. Okay. 7. For each pair of shapes, decide whether or not shape A is congruent to shape B. Explain your reasoning. So it's shape A, so through transformation. So again, let me write, so using rotations, translations, reflections. Can you move this that way so that it lands right on top of it, and that if you place figure A on top of figure B, they line up exactly, then they're congruent. Okay, can we? Well, I can see that we can rotate this guy, right? So we can take this guy, so rotate it, right? Rotate it 90 degrees, so we can rotate this. Remember, this is point, so if I put an arrow like this, just rotate that 90 degrees, that arrow is not gonna, that shape is not gonna be like this, right? So 90-degree rotation clockwise, and after I rotate that, I would definitely do a translation. And does it look like it's gonna be right on top? It does. Just a second again, I'll check the printer. All right, sorry, printer problems. Almost back. Forgot you guys were waiting. I ran out of ink. All right, so this would definitely be a translation. Notice that, again, the two shapes are identical. you can see that they're identical. And I am going to, let's see if I can do this. Take a picture. Well, I can do that. I don't know if you won't be able to. I take this, took a picture. Oh, come on. Took this, took a picture. What in the world? It's not letting me bring it up. So I hope you can see, and I might be actually wrong, because it does look like this is a little longer over here, right? So I take that back. Or is that just my eyes that are deceiving me? No, it's definitely shorter. I have a ruler over here, so you're gonna have a sheet of paper, this on paper anyway. So if I measured that 1 centimeter, and at the bottom, no, they're the same. I apologize. They're the same. So if they are the same, they're congruent. And it's a translation. Rotation 90 degree clockwise, and then a translation. This one. Oh, this one's tough. How do I get 8? How do I get this to become that? If I rotate this way, no, it doesn't work. If I rotate that way, what if I rotate? Right, what if I rotate 8 this way? If I rotate 8 this way, right? So watch my arrow. It is so if I made a little arrow here. So imagine this was the bottom of my boot, and I put an arrow. And I took my boot and I rotated. My boot would be going rotated 90 degrees. It'd be looking like this, right? So let me just draw it, rotate that. Right, so it looks something like this. Right, so hopefully I'm doing justice or injustice to the boot. Right, so if I took this boot and rotated, now I can see. If I rotated 90 degrees clockwise, and then take this boot and reflect it, right? So imagine there's a mirror here. We're going to reflect it. So I'm going to rotate 9 degrees clockwise. This boot ends up being like this, and now I'm going to reflect this over a vertical line, right? Or if it was agreed over the y-axis, and take this and make the boot look the other way. Right? And then what do I take the boot? I'm going to take the boot up and translate it. That's what I would do, unless you can find an easier way. Be right back again. Hang on. Okay. My poor mom is in the room where the printer is. So, all right, so a rotation, a reflection, and then a translation. That's what I'm looking at. I don't know. Can you figure out something easier? How would you get this to get there? through rigid transformations, rotations, reflections, translations. If you have an easier way, feel free to share with me, all right, or with your peers. All right, again, these were, and again, I can't see it, but on your test, you'll probably see a line like this. Hey, give me this angle, give me this angle and this angle. But since I don't know where the lines go, let's just find all the angles, okay? We have, if that's 150, guess what? This is 150, right? It's two lines crisscrossing. That's 150, this is 150, which makes this, the two other ones, 30, 30, because if it's a straight line, they have to add up to 180, or if you think of it as a big circle, it has to add up to 360. However you want to think about it, that's up to you. 30, 30. And now inside the triangle, I have two angles. And if I have two angles, I can easily find the third one, because it's 180 minus 30 minus 45, right, which is going to give me 105. The sum of the angles in a triangle should equal to 180. So if I have two of them, it makes it very easy. So this is 105. If that's 105, this fellow over here is 105. And then just over here, let's finish this up. That's 45. This guy's 45. Can we find the other two? Yeah, it's 180 minus 45, which makes this guy 135 and this guy 135. Well, then now I want you to take a look at two parallel lines cut by a transversal, which is what we have here. So I remember we told you this group of four angles and this group of four angles are identical to each other. There are certain relationships. So you need to ignore the noise, which is all that stuff, and then focus here. So here are my two parallel lines, right? So this guy here is the same as this guy here. So that makes this 135. And this bottom one, right, they're corresponding, and then this bottom one corresponds to the bottom one, which makes that 145, right? This two are the same angles as these two. Am I missing one? Well, you can use, again, relationships from the angles formed when it's cut by a transversal. We can find that this angle right here, this angle and this angle right here, I don't know if you're going to remember that. Let me draw the transversal again. I got two parallel lines. Right, so we're looking this way now, and we're talking about this angle. This angle over here and this angle are the same. They're called alternate interior, right? So if I know that this is 30 degrees, guess what? This guy is also 30 degrees. But we could have also used the sum of the angles in the triangle to add up to 180 to find that missing angle. And we have 45 and 105. So 105 plus 45 is 150. And if I do 180 minus 150, guess what? It's 30, which we already knew because of the alternate interior relationship. So that's 30 degrees. And then again, this guy on the outside is 130. This ends up being 150. This ends up 150. And then again, vertical angles, opposite angle is 45 here, and this opposite is 135. Pretty, pretty, pretty. All right, this one. Think about the bonus. You will wear mismatched socks on test day. Okay, one sock has to be different than the other. Color, patterns, whatever. Okay. It says which of these sequences of transformations will return a shape to its original position. Well, let's take I don't know. Let's let me get a shape here. Let me get that triangle. So imagine a triangle that's in the coordinate plane somewhere. Here's my triangle, make it a little smaller. Let's do 8. It says translate 5 units to the right. 1, 2, 3, 4, 5. And then move it 5 down. 1, 2, 3, 4, 5. Did it go back to where it was? No. So This one is a big no. Take a triangle. It doesn't matter where you start. Let me start over here. It says go 3 units down. 1, 2, 3. Then 2 units up. 1, 2. And then 1 unit down. Is it back to where it was? In the beginning? Actually, you know what? Let me make an X so that we know. So let's, and I'm gonna draw a little circle over here. Right, that's where we're starting. So take this triangle, right, and move it 3 down. 1, 2, 3. Move it 2 up. 1, 2, and then move it 1 down. Is it back to where it started? No, it's not. I'm not gonna say the word. Rotate this triangle 120 degrees. Oh my God. Counterclockwise. All right, guys, I don't even know how to, well, if you rotate something 120, I'm going to use a protractor. I'm going to cheat on this one. Let's go back here. Tools, there's a protractor somewhere. Back to protractor. Good. So, if I'm here, right, you're here, and that's 0, and you rotate 120 degrees, so you have to look at the inside line. So 0, 10, 20, 30, 40, 50, 60, 70, 80, you're rotating all the way up to here. And what is that thing said? And then rotate clockwise. So I'm going to change the order, but it's okay. So rotate 120 one way and then 240 the other way. Okay. So if I rotate from here and I go 120 degrees that way, stop. And now I go 240 degrees the other way. So 120 and then another 120. Do I end up back in my original state? Absolutely not. No comments. What about this one? Take this, reflect it over line L, and then reflect it over line L again. So this one sort of makes sense. So if I have that triangle, and let's call this line L. I mean, it doesn't tell us, it doesn't say where line L is. So if I take this triangle and reflect it on this side, it's going to go like this. Right? And then, so reflecting it that way, it becomes like that. And if I reflect it over the line L again, it goes back. So that is the only one that returns the original shape back to where it was. Okay. Let's move on. I'm almost. Soundtrack provided by. Okay. Here are 3 pair of figures. In figure 1, in pair 1, which transformation takes figure A to figure B? Is it a translation, a rotation, a reflection? Well, I am going to say, let me get it over here. It's a reflection. So if I put a mirror here, right? I hope you can see that this was a reflection. Every point is equally distanced from the line of reflection. Look at that point. They're 1 unit away from the line of reflection. Take a point here, take a point here, and 3. 1, 2, 3, 4. 1, 2, 3, 4 units away from the line of reflection. So that works out, so it's a reflection. 2. Which transformation takes A to B? A to B. So it's, I'm going to put a little antenna here, point it up. And B, here's the antenna pointed up. So no rotation, no reflection. It just means that this guy here got translated a little bit to the right. So it went a little bit to the right, and then it went down. Right, so there's no change of directions there. C, right, so C, how should I do this? Put an antenna here. The antenna now is pointing this way. So how did that antenna end up being here? Well, it wasn't a translation, right? Because a translation keeps the same direction. It wasn't a reflection, because they're not, that doesn't look like a reflection over any line. So definitely a rotation. So this might be a little tricky. So you might need some colors when you do it, even on your test. What is this? Use some colors. So here we are. We have a triangle. Clear objects. We have a triangle. JKL. Here's our triangle. JKL. And JKL was translated so that point J was moved to point K. So point J was moved to point K. So imagine this point right here in the corner. Change colors. Imagine if you took that point. Change colors. Right, so now let's see if I can move. Come on. Sorry. Let me do it again. I made it. Now take point J. So if you're moving point J, you're moving the whole triangle. And move it to point K. So that triangle moved right here. And notice that they're exactly the same triangle, right? So point J, take another color, got moved, and now it's here. Okay. And then that same triangle was moved to point K. Did I just do that? Oh, sorry. The first one's point L. So I'm going to create a new one. No, it's okay. So one triangle got moved here, and the other triangle got moved here. So I'm going to highlight the third triangle. And the one thing you have to know is that all three triangles are exactly congruent to each other. They're all the same triangle. Okay. Identify at least two pair of congruent sides in the figure. Explain how you know they're congruent. They're congruent because it was moved through translations, and translations are what? Rigid transformations. They keep the same size, same side length, same angles. So I know, for example, that this line over here, this side over here, and this side over here, and this side over here are all the same. If I took another, I know that this side now represented with two lines, and this side are all the same. Okay. Yeah, well, that's about it. Oh, sorry. It says name a triangle. Name a triangle. Move this up. Name a triangle, says that's congruent to triangle LKN. So the triangle in the middle shares this side here, the one that has one line. It shares one of the sides that have two lines, and guess what? This side here, and this side here are all congruent, right? So the middle triangle also has all three sides. So any triangle that is congruent to LKN will share those three sides, and in this case you can write triangle JKL, triangle LPN, triangle KMN. Those are all congruent to that triangle. Okay. What is the measure of angle LKN? Oops, what's that measure of that angle over here? LKN. Well, we know that let's start filling this angle. So if this is this angle right here, if that's 41, so they're all the same triangles, right? If that's 41, this guy's 41. Are you okay with that? So can we find the missing angle? This angle right here, can we miss? We know that one will be okay. So it's 55 plus 41, which is 96. We're going to subtract that from 180. So 180, oops, minus 96 gives us 84. So that angle here is 84. We have that angle, which is 84. So we can start filling in our numbers. So we can copying the same three angles in all three triangles. If that's 41, this guy is 84, and this guy here is what? 55. Right? Same thing here. This guy is 84, this guy is 55, and this guy is 41. So how do we find this middle angle here? Well, isn't this 180? That's a straight line right here, right? So if that's 180, right? And we add 41 plus 55, which already did 86, which makes this angle here, right? Angle 84. Now it's a little bit messy, but hopefully we'll do a better job tonight. 12. Explain why figure B is not the image of figure 8 after rotation. All right, so it got rotated. So figure B got rotated, but is this is it an image of figure 8? Well, it's not, right? You can clearly see that this guy right here and this guy right here are not the same length. Okay, so in rotations, reflections, translations, they have to keep the same side lengths, right, in the same shape. So you can say that. 13. Here's point A and located at -4, -4, 3. What are the coordinates of each point? Okay, so let's do that. Let me just write here that this is -4, 3. -4, 3. Well, let's do A. Point B is the image after rotation of 180 degrees. So rotate this 180 degrees. Well, if you rotate this 180 degrees, remember your hands, rotation. The -4 and 3 is going to change twice. It's going to be 3 and 4. I'm going to ignore the signs, by the way, and then 4 and 3. So if you switch hands once, right, for 9 degrees, switch hands another time for 180. Now it's going to be 4, 3. But in which quadrant? Remember, every 90 degrees, this point travels one quadrant. So it's going to go one quadrant over and another quadrant. So it's going to land in quadrant 4. And in quadrant 4, the first number is positive, the second one is negative. So in quadrant 4, -4 and 3 is going to be 4, -3. Okay. B. Point C is an image of A, point A, translated 2 units to the right and then a reflection over the x-axis. So let's move this A 2 units to the right. So it travels 1, 2. So now it's here. And it's going to reflect over the x-axis. Who's your x-axis? This is your x-axis right here. Right? So let's rotate this point to this side. Reflection. So let's count. That's 1, 2, 3. So its reflection is going to be 1, 2, 3 right here. What's this point? This point is -2, -3. -2, -3. Right? It was a translation. So move it 2 to the right and then translate it over the y-axis, x-axis. D. Point D is an image of A after a reflection over the y-axis and a translation. Let me move this. Translation 2 to the right. So erase this. So we're going to go over the y-axis. Which one is the y-axis? So let's draw a line so you don't forget. This is the y-axis. So let's reflect it. So point A is going to be 1, 2, 3, 4. On the other side, it's going to be 1, 2, 3, 4. So it's going to land over here. And then it's going to go 2 units to the right. And then translation 2 that way. So it's going to go 1, 2. And this is the main stop. So what's this point? This point is 6, comma, 3. Okay. I think this is the last question. 14. There's a point again. Point B is the image of right after. So we're going to take this point, reflect it over the y-axis, and then a translation 3 to the left. 3 left. So let's translate. So here's point A, reflect over the y-axis. Where's my mirror? Here's my mirror. So let's count. 1, 2, 3. So on the other side, it's going to be 1, 2, 3. So that's my reflection, and then 3 left. 1, 2, 3. And that's my final point, and that point is -2, comma, 3. Okay. C is an image of A after reflection over the x-axis. Ooh, I think I did that wrong. I'm going to go back. This was wrong. So I did it wrong. So I'm going to do A again. So A says reflection over the y-axis, and here's my y-axis. I did that completely wrong. Oh my god, sorry. So reflect 1. On the other side, it's going to be 1. So this is A prime, right? Or C, as they call it, C. And then we're going to do 3 units to the left. So first reflection, and then 3 units to the left. 1, 2, 3. There is C. So C, I meant B. So B, because we're doing this one, right? B, so we reflect it over the y-axis, and we count 3 to the left. So the answer is -4, comma, -3. Okay, sorry. Now I'm going to do this one, B. Okay, so B is take point A, reflect it over the x-axis. Now this is the x-axis. Reflect it over the other side. So how many units is that? 1, 2, 3. On the other side, it's going to be 1, 2, 3. And then a translation of 4 to the right. Then we're going to go 4 right. So let's count. So from here, we're going to go 1, 2, 3, 4. And this is point C right here. So point C, where is it? It's on 5, comma, 3. 5, comma, 3. Last one is a rotation. Okay, so we're going to rotate this around the center 180 degrees. So the point here is 1, comma, -3. We're going to do rotation. So 90 degrees becomes 3, 1. And then another rotation, another 9 degrees, it becomes 1, 3 again. Yeah. So it's going to go, A is going to go 1, 2 quadrants over. It was in quadrant 4. We went to quadrant 3. Now it's in quadrant 2. And what is it in quadrant 2? 1 and 3, but in quadrant 2, the first number is negative, the second number is positive. So it's going to be -1, comma, 3. So -1, comma, 3. And that's the rotation of 180 degrees. That's it. Okay. O